All right, let's turn our attention to this one. Very similar to the last problem that we did. And again, we can tell that this is a hyperbola because we have one fraction positive and the other one is negative. Okay, and since the x one is positive, we're opening out to the sides. So there's a lot of stuff that we know right away. Now let's start answering these questions, right? So starting here, we can see that our a value is 3, and from here, the b value is 4. And we want to find c squared so that we can find c. So c squared is equal to 9 plus 16, which is 25, and that means that c is equal to 5. Finally, a nice value for c. So we're opening up in the x direction. Let's try to draw a quick sketch of this. Man, one of these days I'm going to be able to draw nice lines. Doesn't seem like today's the day, though. All right, so your center, let's go ahead and get that here. The center would be the ordered pair -4, -1. And again, make sure that you're pulling it from the right stuff. So the x coordinate is coming from this x set of parentheses. The y coordinate is coming from here. So go 1, 2, 3, 4, and then down 1. So this is going to be my center. Since my a is 3, that means 3 units to the left and to the right is where I'm going to have my vertices. And not because a is 3, but because I know I'm opening out in the x direction, so the 3 is coming from underneath the x. So it tells me how far from the center I am for those key points. And then for the y, I'm up 1, 2, 3, 4, and then down 1, 2, 3, 4. Well, it's not really accurate, it's not really pretty. But again, it's about understanding the concept here. All right. So let's go ahead and talk about my vertices. They were 3 off from this guy in the x direction, so 3 to the left is -7, -1. 3 to the right is -1, -1. My foci will be very similar, except now it's going to be 5 in that x direction. So 5 from this is -9, -1, and 5 on the other side is +1, -1. All right, so that we can answer the rest of our questions, let's go ahead and draw our rectangular grid. So we're going from the center up 4 and down 4, to the left 3 and to the right 3. And our asymptotes are going to be, again, it's just going to be these diagonals. And to finish drawing my graph, I start here at the vertex and I start to curve out and get closer to the asymptotes. Is my graph perfect? Not in the slightest. But seeing the graph, it gives me a really good idea about where things are, and I can answer all the other questions. So let's talk about what the transverse axis is. Transverse axis is the line that goes through the center and the foci. So it's going to be this guy right here. A horizontal line, and y equals, it's going through the center, y equals -1. Your conjugate axis is going to be perpendicular to that. So he's going to be this guy right here. It's a vertical line. X equals, it goes to the center. X equals -4, right? The transverse and the conjugate axes, you can pick those guys up from the center, but you have to know the orientation first. You can't just say, oh, the conjugate axis is always x equals. No. Because if the hyperbola are opening up and down like this, then the conjugate is a horizontal line going through the center of that. And the asymptotes. Okay, so again, we're basing it off of the center. So it's going to be y plus 1 equals plus or minus. It's always b over a. Because remember, slope is a rise over run. Change in y over change in x. Change in y is the 4. Change in x is 3. So plus or minus 4/3. And then x plus 4. Asymptotes. Done. Because see, I wouldn't make you then write each of these in slope-intercept form. Point-slope form is fine. We're just trying to make sure you understand the concept and you know where they come from. The domain. Well, because I open up to the side, I've got that big gap in the middle. So I'm coming from negative infinity up to this x value, which corresponds to one of my vertices, and that happens at negative 7. Bracket. Union. I pick back up the other vertex, which is starting when x equals negative 1, and then go to the right toward infinity. And my range, because of the orientation, goes all the way up, all the way down. We got it, right? You find your A, your B, find the C, get a sketch of the graph, and answer everything else. Now this next one is one where I would say don't graph, at least not on a graphing grid. It's not going to fit very well. But what I need you to understand is that numbers are just numbers. And for those of you that have ever been my students, you know I say that all the time. You can't let the size of a number throw you off or scare you. Okay? Numbers are just numbers. Again, we have a hyperbola. This whole section is about the hyperbola anyway, so why wouldn't every example be about the hyperbola, right? But even if it were just thrown out there and we had to figure out what to do, you've got these two fractions. They equal 1, so it's either going to be an ellipse or a hyperbola. Well, because they have differing signs, it's a hyperbola. Since the x fraction is positive, it's going to be a hyperbola that opens out to the side. The two branches are opening out sideways. All right, so let's figure out what we know about this. From here, that's my a squared. So a is going to be the square root of 225, which is 15. B is the square root of 64, and that's 8. Now we find C, starting with the fact that C squared is equal to the sum of these denominators. So 225 plus 64 is 289, which means C equals the square root of 289, and that just happens to be a perfect square, 17. Boy, that's super nice, isn't it? All right. The center. From the x, we get positive 19. From the y, we get positive 54. Sounds okay? So we have the center, and we understand the orientation, right? So you have your center right here. You're supposed to have your two vertices, and these guys are going to be out to the left and to the right, because we know that we have this opening of the hyperbola branches to the left and to the right. All right. So how do we get those two vertices? Well, the distance from the center to that vertex is 15. We get that 15 from that number that's underneath the x part. So I'm going to add 15 to this. So 19 plus 15 is 34, so 34, 54 is 1. Subtract 15 because you got to go back to the left, and that would give you 4, 54. Your foci are going to be the points within the curves, so this is going to be one focus, and that's going to be your other one. What's that difference? What's that change? Well, we found that C is 17. So it's going to be from the center plus 17 to this. So 36, 54, and then minus 17 from that. So 2, 54. So far, so good. Your transverse axis. First of all, you got to make sure you understand if it's horizontal or vertical. Because of the orientation, you got the center and the two foci out to the left and to the right. Your transverse axis will be the line that connects all of those. It's horizontal. It's going to be y equals, it goes through the center, so y equals 54. which means your conjugate axis is just going to be x equals 19. Because it's going to be that vertical line that goes right through here, and x equals what? X equals 19 for the center. Now the asymptotes. So we start with the y, so y minus 54 equals plus or minus, as we keep saying, it's b over a. So in this case, 8 over 15. So 8 over 15, and then x minus 19. Easy peasy, right? Well, the last things we need to address would be the domain and the range. So the domain, you see it's coming from the left, negative infinity, up to this point. And what's the x value? That's a vertex, so look back at your vertices. The one on the left is going to be when x equals 4. Union, because you have the gap, and you pick it back up at the other vertex, so that's going to be 34 to infinity. And then you have your range. This guy goes all the way down, it goes all the way up, so the range is all real numbers. Now, if we were really trying to be a little bit more accurate, then we could say, oh, well, here's our box. We've got to go 15 to the left, 15 to the right, and then we got to go 8 down and 8 up. Okay, this is how you're forming that box. And your asymptotes would be the guys that do this. Oh, I definitely clicked on the wrong part. These would be your asymptotes here and here, right? So hopefully that all makes sense, because the next couple examples are going to be the fun ones where we get to complete the square, and I know that you are totes excited about that. So hopefully you stick around.